This question asks us whether a certain decimal has a finite number of non-zero digits. So let's consider some decimals that have an infinite number of non-zero digits. Well, there are two, broadly speaking, ways to come up with one of those decimals. One is to have a number like 3/11ths, a rational number, which goes on forever and ever, like 0.2727272727. You can see how this just keeps repeating over and over. The other way to get an infinite number of non-zero digits is to have an irrational number, like something like the square root of 2, which is equal to 1.41421, it goes on forever and ever. Seemingly random. Or another example of that would be pi, is 3.141592, etc. So I want to know whether the decimal we're dealing with is like this, where it repeats or goes on forever, or whether it's just like 0.5. So what I've done is I've just listed a bunch of fractions that satisfy the conditions that they've given. Statement 1 says that the denominator is a factor of 100, so that could be like 2 or 4 or 5 or 10 or 25 or 20. And 1/2 is 0.5, 1/4 is 0.25, 1/5 is 0.2, 1/10 is 0.1, 1/25 is 0.04, 7/20 is 0.35. So it looks like no matter what, this decimal is going to end. So statement 1 is sufficient. Now statement 2 says that the numerator is a factor of 100. So I've listed a couple of those here. 4/10 gets me 0.4, but 2/3 gets me 0.666666666 forever and ever and ever. So that's an infinite number of non-zero digits, whereas 0.4 is finite. So statement 2 is not sufficient to tell us whether this thing is going to terminate. So the correct answer is A.